Okay.
Set this up.
Yeah, should be good. You need the display?
Yeah. Well, no, I don't. I have my own.
Okay.
Okay. You're going to move this to your desk, right?
I need to be connected to this
Oh, why is that?
because I recorded through
Okay,
this.
okay. I see. Then we might as well.
If you want, you can just use my computer as, unless you have something on it.
No idea. Well, it was only the Discord that. Hey, that's
Okay, okay.
not the problem open there, right?
Yeah. Okay, should be good. I'm just gonna get the mic, but you can start talking
Okay.
about this. I'll let you take over.
Right. So we're looking at this problem called family visits. Go ahead and read this out.
Could you make it?
Apparently, Ricky is familiar with this problem. You live with your parents?
No.
Thanks. Thank you.
And then once you start, just go here to this e-glass fusion,
Okay.
so people can see what you're writing on the board.
Ah, okay. All right. Okay, so finished reading the problem? You want to summarize the problem for me, Ian?
I didn't finish reading it again, but
Yeah.
I do kind of remember this problem.
Okay.
So every day you make a mess,
Yeah.
and you know how much you can clean.
Yeah.
So you're trying to figure out. Actually, I don't remember that part. So you're trying to figure out how much you need to clean each day, I believe,
Each day?
before your parents do it.
What are you trying to, what's the answer that it's looking for? What are you, what is the,
There you go.
sorry?
I'm trying to see the smallest number of days you have to clean.
There you go. So it can't be every day.
Just in time cleaning.
Sorry?
Just in time cleaning.
You could call it just-in-time cleaning, but really the way you want to think about it is what are you trying to, what is the output needed? So what is the output needed?
The number of.
The number of cleaning days, right? And you could accumulate mess over time and clean it up as long as it's before the next parent's visit, right? Yeah? Okay. So let's look at the input, let's look at the output and see what kind of approach we want to use. So what's the input? The input is for each day we have, sorry? I need to change, yeah, right. 1,000 is all I need, right? Okay, good. Okay. All right. So we are given, think of this as a table. You have 1, 2, 3, up to n days, right? N, I think, is the number of days. And for each one, you have how much mess you create and how much cleaning you're able to do if you were to clean that day, right? And then maybe we need a little more to say, did we clean that day or not? So it's like your cleaning schedule, right? Right. Well, actually, we're going to have some more data that we want to save. So this is what we're given. We're asked to. What else are we given? We're given the specific days when the parents show up. So maybe I'll make this column as the parents' visits, right? So it'll either be 0 or 1, saying which days they show up. Fine. So maybe there'll be some days that I'll star. Those are the days we have parents' visits. Okay. And you're asked as output is the minimum of number of cleaning days. This is what we want. So anytime you see a min showing up in the output, you know that this is what's called as an optimization problem. And what's the standard technique for optimization problems? So it's either dynamic programming or the simpler version, which is greedy algorithm. So question is, will a greedy algorithm work for you? Could we make decisions on when we go and clean up? Why can't we just do cleanup on the day the parents show up and be done with it? The problem is that if you let too much accumulate on the day of the parents' visit, you may not have enough cleaning hours to clean up. So you may not be able to clean all the mess that got. So we know here that the parents are showing up for the first time here, and there's a whole bunch of mess that got accumulated until this day, and we don't know if we can do all that cleaning over here, right? So we may have to clean up more, and if we clean up earlier, it reduces the remaining mess that you have to clean up on the day of the parents' visit, or it's possible that on the day of the parents' visit you don't have to do any cleaning whatsoever. That's also possible. So it takes some work to kind of figure out that greedy algorithms will not work. And that's not easy. I do encourage you to go and think about it, why the greedy algorithm will not be enough, or where it'll fail. There are some challenges to it, but the end result is that dynamic programming is pretty much the only way we know how to solve, assuming that greedy algorithms don't work. Now, if you've attended my class, you already know that the first step in solving dynamic programming problems is to write a recursive solution. So in order to do a recursive solution, what we want is to, well, we want to minimize the number of days, so number of cleaning days. So we're going to have the output be the number of cleaning days, and this number has to be as small as possible. So what we need to do is to write a recursive program that does this computation and gives out an answer by looking at this entire table. And the way we're going to go about this is to say the following. We're going to say f. Let's call the output, the number of cleaning days, to be f. The number of cleaning days at the end of at the end of n days, we want to know where we allow for this much of a mess that's still left over. Okay, so we're saying what is the minimum number of cleaning days that I need in order to take care of n days, look at the schedule for n days, and at the end of it, you leave a mess of R. If the parents are visiting on the last day, then this R better be 0, right? Because you can't allow any mess if the parents are visiting. So R needs to be 0 whenever the parents are visiting. But if they're not visiting, the amount of remainder cleaning will accumulate or will vary based on when was the previous time you cleaned. So we're going to say, and by the way, over here, if the parents are not coming on the last day, then really I can pretty much stop cleaning at this point. I don't have to worry about cleaning after this because I don't care, right? So how do we handle this? Essentially, if we're going to make sure that R is 0 whenever the parents are showing up. Okay, that's going to be the F. So I'm going to write down Fn comma R, or in fact, I'm going to call this F of, you'll see that I'm going to write this as F of I comma R as, well, you guys are used to writing the recursive program, so let's start with the recursive program. So the recursive program of F with the parameters being n, all this stuff, m, c, and then some remainder mess that we leave. We want to output right. So we're going to say if n is equal. Well, let's forget about the base cases. Let's try and write down the recursive, the core of the recursive program. And the core of the recursive program is going to say that we will return something like this. It's either going to be f of n minus 1 with a bunch of things, or it's going to be f of n minus 1 with a bunch of things plus 1. So either we'll do cleaning on the last day or not. Right? These are the only two possibilities.
Should there be a minimum?
Yeah, there should be a minimum. You're right. So it's going to be minimum of these two things. Okay. So yeah, let me write that better. And
Should we maybe turn the lights out?
yeah, please, if you don't mind. Thank you. So we're going to return a minimum of these two things. Okay. Either it'll be like so or like so. Now the question is, what are these other parameters that we have to deal with? By the way, since m and c don't ever change, I'm going to just leave them out. Okay. Over here, I said that R is the remaining cleaning up that I need, right? And also that remaining cleaning up will change depending on whether the parents visited or not. So we're going to say something like if parents are visiting, so let's say if p of n equals true, that means the parents are visiting on the nth day, then what do we do? Then this R better be 0, right? Well, if you're cleaning, you're going to clean. Well, yeah, you're right. You don't. If you're going to clean, you might as well clean the maximum. because there's no point in because you're going to count that one day anyways. You might as well use up all your time and clean up as much of the remaining mess as possible, right? So what we're going to do is I need to figure out what to write here, right? This is really the tricky part of this recursion. Now, if I want to leave R with, so actually I don't need to know if P of n equals true or not. Let's just forget about that.
Yeah.
Okay. Either I clean on the last day or not, and of course if the parents are coming, I better clean up. I may or may not clean up, by the way, just because the parents are showing up, because it's possible that that day I didn't create any mess, and there are days when the mess level is 0, right? So really it has nothing to do with the parents' visit, but there are certain days when the R better be 0, which is the remaining mess that's left in the room. So over here, what do you think I should put down in this portion? So if I'm not cleaning, how much mess would have been there on the previous day? By the way, I'm assuming that R is the mess at the end of the nth day. Okay? So that means here I want the mess at the end of n minus first day. If I didn't clean on the nth day, how much mess would have been there at the end of the n minus 1th day? What do you think? Sorry? Cumulative of what? Sorry? So first of all, remember now I'm looking at the previous day. So it shouldn't include what? It shouldn't include the mess I created on the nth day. So therefore, the remaining mess at the end of n minus first day would have been how much less?
No. The mess you created on the end.
So here the amount of mess I create here is m of n, right?
M of n minus 1.
No, it should just be m of the last step. The mess you created on the last step.
It's going to be R minus m of n. Does that make sense?
Yeah.
If I ended up with the mess of R at the end of the nth day, on the n minus 1th day, if I didn't do any cleaning, I would have R minus m of n of a mess, right? And I want to know how many cleaning days there were in order to achieve that. If I did achieve that, then I can achieve n comma R. Fine? This R can be 0 if there is parents showing up. Otherwise, it could be any number you like. Is that clear? Now let's figure out this one here. Here I'm assuming that I cleaned on the last day. So what should I put here?
Oh, it would be all of
I may not be able to take care of all R. Remember, it's possible that things are accumulating, and I just say, okay, even though my parents are not visiting, I don't have too much time tomorrow, so I'm going to do some cleaning today, and I take care of it. So it doesn't have to be all of the remainder. This is something you need to be clear about. Okay, so the question is, what's this number going to be?
R plus m minus c.
R minus?
R plus m minus c.
Minus c, that's right. So is it plus m or minus m? Remember, the nth day didn't happen at that time, right? So it should be, so it should be R minus m of n but plus C of n, because that's the number of hours I have for cleaning. That's the amount by which it would, did I get this right? No, I didn't get this right. Something is not right. Yeah, actually you're right. So this should be R plus M, is it? No, 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 that doesn't make any sense. That is,
the mess of the current day.
sorry?
I was thinking I needed to add the mess of the current day. I might be getting confused.
Yeah, no, but because you're now looking at the previous day, not
Oh,
today,
okay, yeah.
right? So you're looking at the previous day. Today I did this much cleaning, C of n,
M of n minus 1, R times M of n minus 1.
not n minus 1. The
Actually,
cleaning happened today, and the mess I created was today. And R is the is what I have at the end of the day. So what's that going
cause
to
a problem if you clean more than.
Right. So we'll take care of that. But first, tell me which is plus and which is minus. So I'll have this much less. Yeah, I think it has to be minus m of n plus c of n. Isn't that right? That's not right. Is it? So in order to take care of the case when you have too many cleaning hours, I am going to do a min with 0 so that it never becomes negative.
Yeah.
Okay, so I have to modify this, and I'm running out of space there. So let me rewrite this in a nicer way. This screen is small. That's one of the problems with it. So I'm going to write this as 1 plus f of n minus 1, comma, and here I'm going to do minimum of 0 and what?
Should there be max of 0?
Max of 0. Thank you. Max of 0 and so today's cleaning should reduce the remainder. So should it be? Well, first of all, you had this much less that day. Oh no, you did create the mess. So it is going to be just
R minus the clean.
R minus the clean. But then where is the m of n coming up? You cleaned up and you ended up with R, right? So therefore, it should be R plus C of n. Yeah, so what I had earlier was right, R minus m of n plus C of n. And of course, this is max with 0. Don't believe this?
Makes sense. It should be opposite, right?
It feels like it should be opposite, but then R is what you're ending up with. Okay, so it's you started with R prime, and then you added some mess to it, and you cleaned up some mess, and then the result was R. So if on the previous day the mess was R prime, you added this much to it, you subtracted this much to it, and it became R on the nth day. And therefore, R prime is R minus m of n plus C of n. Oh. What?
Okay. So we're just covering the.
I see. Does that make sense? Right? So then the mess on the previous day must have been that. right? So I'm going to erase this part. So that's my recursive program. Essentially, it says if you want to report f of n comma r, return the smaller of these two values. But you can't just do smaller of these two values. You have to make sure that if the parents are visiting, that you throw away one of them. Right? You can't use this guy if your parents are visiting unless r is already 0. Right? And I think even here you have to do minimum with maximum with 0, right? Because r minus m of n, no, it can't be. It can't be. Yeah. Because it's fresh, it has to be r minus m of n.
I don't want to mess up everything, but just on the bounds, this r,
Yeah.
you can have like a case for
1,000. Yeah.
not just 1,000, but like there's 1,000 days. So let's say it accumulates. You only accumulate on the first 500 days. And so you basically end up with 500 times 1,000 trash, and you're only able to clean in those last 500 days. And then that R your R must be 500 times 1,000, and now your state is big.
But both your m and c are less than 1,000. But you don't have that many hours in a day. That could make the problem a little too big. We'll get to that in a second. So let's see. There are some concerns as to whether this is feasible or not, and I'll explain why those concerns happen. Did everyone understand this general formulation? Yeah? So essentially, in order to solve f of n with a remainder of this much trash, this much cleaning up, you need to solve two other recursive calls. You make two other recursive calls or solve two other subproblems, both with n minus 1 days, but with different remainder trash, remainder mess work, cleaning up work. Okay? Now, right. I think you need a max with 0 even here. Is that right? Not sure. It's always safe to put it anyways. No, it can't be needed. No, that's fine. In fact, R needs to be can R be less than m of n? Even if you don't clean up that day, it's not possible. So yeah, I don't have to worry about that. Okay, fine. Now, what are the base conditions here? Base conditions are when n equals 0, right? Which means you've taken care of all the days. Or when n equals 1, that's enough for a base case. If there's only 1 day to take care of, you can leave as much mess as you want, conditioned on whether your parents are visiting or not. So if parents are visiting, the only thing you have to worry about is r equals 0. Otherwise, you have to try every possible value of r. But really, there is only 1 day. There's only so much mess you're creating. And so all you have to do is for n equals 1, you only have r equals m of 1. And that's it. Okay? So essentially, you're going to say if n is equal to 1, right, then and parents are visiting, and p of 1 is true, all right, then then we are going to say f of n, return. Then you're going to return 1 if the mess you created is non-zero, otherwise it's a 0, right? So return return 1 if m of 1 is bigger than 0. So if you're creating some mess, you better clean up that day for whatever it's worth. Sorry, actually, we have one more case to worry about, and that's if it's not possible to clean up. If the mess you create is larger than the cleanup time, then you are not going to be able to clean up, and then you give up and face punishment. So we really have to worry about 3 cases here. We are going to either return 1, 0, or -1. So we need to write down those 3 cases. So 1, 0, or -1. 1 is going to be if parents are coming and the cleaning time you have is at least as large as the mess you created. 0 if parents are not coming, or if the mess you created is 0, and -1 if the mess you created is larger than the cleanup you do. I won't write all that, but all that goes in the base case. Otherwise, you go and do what we said over here. And over here, if the parents are visiting on the nth day, then we cannot apply the first case. We can only apply the second case, and we only return the second of the 2. And you don't just return the second of the 2 if the cleanup time you have is more than the remainder. You can forget about it. You just report -1. Otherwise, you report 1. Fine? So those are all the things that you have to worry about here. Okay? Now, this version, what I assumed here was that we know that n can be as big as 1,000. Right? We are told that n is at most 1,000. We are also, so I had assumed that r was also at most 1,000, but Ricky just pointed out that each of these values are known to be at most 1,000. All right. So if you look at 1,000 days of mess, then the accumulated mess could be up to 1 million in the worst case. So if you do that, then this table becomes too large. It becomes 1,000 times 1 million. That's too much. How do we take care of this? Right. So, okay, I think this is fine. Theoretically, we're going to use a table that looks like this. This table F is going to have n rows. We may have to add an extra row at the top, I'm not sure, but it'll have n or n plus 1 rows. We'll figure that out. And in terms of the columns, you would have 0 mess, 1 mess, and we'll go not sure up to what. Let's just say here 10 to the 6. All right. What we want at the end is we want the result for the nth day. At the end of nth day, how many cleaning days minimum number of cleaning days we need. If the parents come, then this is the value I need to return, right? Because we want to make sure that at the end of the nth day, you're left with a clean house because the parents are going to show up. If they're not going to show up, all I care about is I just want the smallest number in this entire row. That's all I care about, right? Is this clear? So I don't care how much mess there is left over, but it's, well, actually I only have to go up to 1,000. So, no, it could be any amount. Forget it. Yeah, it could be any amount here, but I just want the smallest value there. So either I'm going to return this guy here if the parents are visiting on the nth day, or the smallest of all of this. That's my final answer. Oh, sorry.
I need to get rid of this.
Yeah. There is a way to do it. I think it's under settings. There's an arrow bar. Where?
Oh, yeah, you're right.
Oh, there you go. Got it.
Thank you.
Is this making sense? Yes?
No.
Well, I still have to explain your objection,
Okay.
but this is just to say where the final answer is.
Okay. Yeah.
Now, your concern is this table is too big. If I start to fill everything in this table, I'm in trouble. But what I'm going to tell you is that the number of non-zero entries in this entire table is not that big.
Okay.
So that's what I have to kind of maintain. So let's take a look at that. I'm going to erase this left part here. Any questions about this?
The table is your memorization table?
No, it's not.
Oh, what table?
This is just input.
Oh.
The memorization table is right here. F
That's
is
what
my.
I meant, that table is the one
Whatever you return, that's what you need to memorize. And there may be some other things. We'll see if there is need for anything else. But for now, F is what you're memorizing. Okay? All right. So now, question is, if I have 1,000 rows and 1,000,000 columns, I'm dead. It's because the number of computations is a billion, and that's too many, right? So question is, how do we make sure that it doesn't go up to a minimum, it doesn't blow up to this crazy amount? Well, first of all, we're not going to solve this recursive version. Instead, we are going to turn it upside down and go bottom up, right? If we go bottom up, then the question is, what are the rows, what are the entries that I start to fill up in the table? And if I do that, let's think about what the first row is going to have. By the way, do I need the 0th row? I don't think I need the 0th row. So let's look at the first row in this table. So the first row is this. I remove the 0. I don't need the 0. I only have 1. So question is, what happens in the first row? In the first row, either I clean up or I don't. I'm assuming that only one day's data is there. I don't have to worry about it. If the parents don't show up, I don't clean. If the parents show up, I clean. So all I'm going to do is I'm going to say f of 1, comma 1 comma 0. That's, I need to keep this clean, right? It's either going to be so if I cleaned up, it's either going to be 1 or 0 or -1. let me tell you why all these cases show up. It shows up if it's 1 if C of 1 is at least as large as M of 1, meaning I can clean up the mess I created. It is 0 if C of 1 is 0, or parents don't show up. Okay, false.
M of 1 equals 0?
Sorry?
M of 1?
Is it M of 1? Oh, M of 1. Sorry, yeah, you're right. Not the cleanup, but the mess. Yeah. Yeah. I don't create any mess, so it doesn't matter whether I have cleaning up time or not. If I'm not creating any mess, I don't need to clean up, regardless of whether parents show up. But if the parents are not coming up, I don't have to worry about it. I can call it 0. Oh, wait. If I do 0, I have to then. No, this is not right. Okay. Right. And the third case is parents are coming and I don't have enough time to do the cleanup. So the cleaning up time is strictly less than the mess I create. Right? There is one other case, and that is if you're not cleaning, then f of 1 comma r, which is the remainder that you will have at the end of that day, is going to be m of 1. Okay, and this here is going to be strictly 0. Is this clear? Does this make sense?
Why is that strictly 0?
Well, for that you have to understand what f is, which is what I wrote. Did I write down anywhere? I never wrote down. Okay, let me write it down. Okay, f of I comma r is the minimum number of cleaning days okay, given schedule for the first I days. For I days, leaving a cumulative mess of R.
Oh, so you're allowed to leave M of 1 on the right column.
Well, if you're not going to clean up, you're stuck with M of 1, nothing else. That's the amount of mess you created anyways, right? So if you don't clean up, that's what you're going to be left with. So f of 1 comma m of 1 is going to be 0. All others are not even allowed. They're actually minus 1 or something like that. Well, what are they? Well, they're not solved problems. Infinity, can it be infinity?
Invalid.
Well, at the end of one day, you're going to have at least this much mess. Well, you're never going to have more than this much mess. So anything less than that should just be negative 1, right? No, negative 1 is kind of annoying. It is not possible to finish the first day, not clean, and leave a mess of less than M1. So whatever notation we want to use there, we need to use that notation. Negative 1 should be okay.
I think one way to get rid of the negative 1 is when the parent first comes, that's one problem. and you know at the end of that
I know,
day,
we could use two separate matrices, that's what you're saying.
No, I'm saying like, once the parents come, you know you have to have 0 mess,
Yeah,
or you have to report -1.
yeah.
But if you know you have 0 mess, the problem just restarts at that day.
True. So in fact, that I'm going to address by saying, in my next row, I'll only fill up some entries. Or automatically, those are the entries that will get filled up. And we'll know exactly which ones they are. It will depend on the previous row. So I'll explain that in a minute. But is this definition clear for f of I comma r? Essentially, it says how many cleaning days do I need if I have to leave that ith day with a mess of r. Okay. And this r can be any number between 0 to whatever. And for the days when the parents visit, the only value I'm really interested in is with the remainder to be 0. Okay, so that's what I need to know. Now, I'm going to now set up a loop that fills up, that doesn't necessarily fill up this entire matrix, but starts to fill up in some specific ways. In the first row, I only have 2 entries I'm going to fill up. One is for column 0, and the other is for column m of 1. In the second row, I am, for any of the rows, if the parents are visiting, I don't even have to consider the m of 1 mess. I only have to take care of the 0th column. Nothing else will get filled. I don't even have to fill them because there's no point in even looking at them. Does that make sense? Right? Yeah. So on any of the days where the parents are visiting, I only care about this one entry here. Everything else will actually be left open, will be left empty. And then anything after the last visit by the parents, I'm not even going to bother filling it. It's just going to be I just take the answer for that last day because I'm not cleaning after that. Okay? Yeah. And so now we are, we have to write this code for how to fill up any entry of the ith row. Well, it's not any entry. We are only going to fill up some of the rows. For every non-zero entry in the previous row, there are specific entries that will get filled up in the next row. I think that's what I was trying to tell you.
But at each row, you can basically, the previous entries can get multiplied by 2.
Correct. Right.
And
That's
then
okay.
I can fill up the whole row.
That's okay, because that'll just say that it can go up to 2 to the n. This thing is going to be it's a pseudo polynomial time algorithm. I don't know if that makes any sense to you. It's just like knapsack. It's really an NP complete problem that you're trying to use dynamic programming for. In reality, it's not a polynomial time algorithm. It can blow up depending on how large your in this case the 1,000 is. Since 1,000 is a constant, you're never going to go beyond a certain number. Even with the knapsack problem or the change problem, those are all NP complete problems. They're not polynomial time.
Yeah, but they're dependent on that size of the knapsack, which in this case, kind of our knapsack size can be 1,000 times 500.
even if I go the opposite direction, let's say that I look at the last day that parents show up, and I try to fill up this entry. In order to fill up this entry, I'm going to have to take a look at two other entries on the previous row. So I don't know, this one and this one, and then when I try to solve those two, it's going to ask me for two things for this guy and two things for this guy, and it's going to continue to multiply, but it's never going to be. Can this number be as big as 10 to the 6?
I give you powers of 1, powers of 2, 1, 2, 4, 6, 8.
Right.
Now your choices, you can generate any number.
No, you cannot. It can only only to the extent that you because you can't use multiple copies of each one.
Why can't you use multiple copies?
Wait, you're saying that your m values are going to be 1, 2, 4, 6, 4, 8, and so on. That's what you're saying?
Yeah.
Then look at it this way: for some row to have a million entries, the previous row must have 500,000 entries, and so on and so forth. So the number of columns has got to be log of the million, which is roughly 30. Right? 20 actually. And therefore we have this thing going up to 1,000, so it could easily fill up your rows and make your thing very expensive. I need more time to verify whether this makes sense or not. You're convinced it won't work, or it could blow up in terms of time complexity? That's what you're saying?
This is going to blow up in memory limit, too much time.
Yeah. You're,
Did you saw this one? There's a conflict.
Yeah. got the same recurrence. The only
Hmm.
thing I did was flip. Instead of doing day, I do trash. Oh, sorry. Instead of you're doing the trash, I do day.
Uh-huh.
Then you know you cannot do more than 10 days.
I'm not sure if I'm following your definition.
F of ND is the minimum amount of trash on the ith day after I days using J cleaning days or D cleaning days.
Uh-huh, I see. Okay. All right, let's redo this then. So let's call this R. You're saying on the ith day using J cleaning days. What is the minimum amount of trash, minimum quantity of mess, given J cleaning days out of I, right? This is what you're saying.
J cleaning days on the ith day.
Including on the ith day, is that what you're saying?
It includes the ith day.
Okay. So how do I rewrite this? Given that the that the jth cleaning happened on the ith day.
It could have happened. I'm saying it's including that day.
Well, then that's the same as what I'd written earlier.
You had wrote. It confused me when you said the I, like day.
It did J out of the I days. That's all I
days,
said.
yes.
First I days.
Yeah, I didn't see that.
Okay, yeah, that's what I said. Given that that J cleaning days occurred in the first I. Is this what you're saying? Okay. All right. Good. So if this is so, then what's the recurrence going to look like? Okay, so we have R of ij. We need to write down a recurrence for this. So if you cleaned up on the ith day, then you're going to have I minus 1, j minus 1. But then you have to, the amount of mess you'll be left with would be whatever cleaning you did on that day, on the ith day. So that's going to be by the way, this is at the end of the ith day, right?
Yeah.
Okay. So
We add mess of I.
you add a mess of I.
And you subtract C of I.
That's the amount of trash you had at the end of the I minus first day. Then you created some mess and you added some cleanup. And again, you may have to do some minimum with 0,
Yeah.
right? Maximum with 0. or you don't clean up, right?
Yeah, and then you keep J the same, but you increase the trash.
So it'll be I minus 1j plus the mess of I. So it's one of these two things. Okay, yeah, I like this better. This seems more meaningful. Okay, so here's the correct solution for this problem. So this is why you need to write this memoization in English, because otherwise it's very hard to get the problem right. It says R of ij is the minimum amount of mess that you leave at the end of the ith day, assuming that you did cleaning up on j of the days. Okay, is that clear? So you're looking at n days. Let me make a box like this. You're looking at the ith day, and you're asking, I did clean up on a bunch of days here, in fact exactly j days, but at the end of the ith day, I'm left with this much mess. Is that clear? Okay, so assuming that this is the definition, now let's see if we can understand this right hand side here. This says R of ij. In order to figure this out, there are only two possibilities. Either I clean up on the ith day or I don't. If I cleaned up on the ith day, then I have to look at R of I minus 1 j minus 1, because I'm looking at the end of the I minus 1th day, and there were only j minus 1 cleaning days in those I minus 1 days, right? So I'm looking at R I minus 1 j minus 1. But then I added some mess and I did some cleaning up on the ith day. So I would have to change this value to this new value, making sure that I don't go negative. And so I add this maximum with 0. Or the second possibility is I didn't do any cleaning up on the ith day, in which case the number of days becomes less, I minus 1, but I still had j cleaning days prior to that, and so all that will happen is the amount of mess on the ith day will add to whatever mess was there previously. All right, so if you do it this way, the nice thing is that R now is a memoization table where I'll have 1 through n and 1 through n. And it'll be 1000 by 1000, and so this table is manageable. And each entry can be filled up in roughly constant time, and I can figure this out. Now, in what order will you fill things up? So you can fill up R of I with j equals 0 pretty easily, because all that will happen is the mess will keep accumulating until the end, right? And so the first column is for j. Well, actually, I need an extra column and extra row here for j equals 0 and I equals 0 and j equals 0. Well, I don't need I equals 0, but I need j equals 0. So I will add that and make this 1, make this 1, and add an extra column for 0. So if I have 0 cleaning days, this is all easy to fill. That just says how much mess. Since I don't do any cleaning, it's just the mess keeps accumulating, right? So the first entry here will just be m of 1 then you will have m of 1 plus m of 2, then it will be m of 1 plus m of 2 plus m of 3, and so on and so forth. So the first column is easy to fill, and then the remainder columns I'm going to fill using the formula that I have here. So for each entry, I have to look at the previous row and possibly the previous column. And so I better fill them up since each column I'm going to go row by row, I would have the values before I need it. And so all I have to do is to do table lookup in order to fill this table up. And then what is the actual, where is the final answer that I need? The final answer that I need is, I'm going to look at the last day when the parents came, and I will ask for the number of cleanup days. I have to find the entry here where the amount of mess left is 0. That's the one that I have to report. So I go from left to right. I find the first value of j where this value becomes a 0. So in order to find the right answer, I find the last time the parents showed up. Then I look at that row. And remember, the first entry is simply going to be a lot of mess because I've not done any cleanup. J is 0. Then I go, as I go further down, the amount of mess will keep going down. And at some point, hopefully it'll become 0. And that's the number that I will report. So the first value of j, where m of I comma j, r of I comma j is 0, that's what I report. Now, what about the case when we are not able to clean up, where there is no answer? How will we know that? Sorry? There won't be a 0. That's right. That's right. Yeah. Regardless of how much you clean on whatever days you clean, the amount of mess will never become 0. Yeah. And because this thing returns the minimum amount of mess, if the solution is possible, you'll see a 0 there. Otherwise, you'll see something else. So you have to initialize this table to, I don't know, infinity, or it's enough to just leave it as the same as this first column, because that's the mess that you have anyways, and it'll start to go down as you do more cleaning. Okay. Thank you, Ricky. Yeah. All right. Questions?
Yeah, this solution seems better because.
Oh, it's not better. This version is correct, and that version was wrong. No.
Well, I think that makes it better.
Sorry?
I think that's good enough to make it better.
Sorry, you're right. That version is not wrong. It's just that it's going to be slow for the values that are given to you.
Yeah. So like I was saying, I think it's better because we're only creating space.
Yeah.
On the difference of like whether we're cleaning or not. Whereas before we had one space for any mess, any value of mess.
Yeah. Oh, you mean for backtracking in order to figure out what days the cleaning actually happens?
In terms of like the amount of space that we have on our table.
Yeah.
Before we had like one space for every single integer of the mess.
Yeah.
But now we just have j, which is did we clean or not.
Right. Yeah.
So
Yeah.
this is the size.
Yeah, the table used is more manageable. Here there are only there are only a million entries, 1,000 rows by 1,000 columns. The other version that I showed you that I started with, that I came up with, had 1 billion entries, and that's going to be hard. All right. Yash had sent some problems, but I don't think we have the time to look at this now. Yeah, I have a minute to spare, so I think I'll stop here.
I have a small question.
Yeah.
If on a day I have some mess,
Yeah.
I clean, and like on that day my parents are not coming, but I just clean.
Yeah.
Still some mess are there.
Yeah.
So that
Yeah.
is the case, the first one where like I managed on.
Yeah, let's do the examples. You're right. It's a good idea to show you how this works with actual data there, right? Let me erase just this part and see what happens. Okay, let's look at the examples. I think the second example is a little more complicated. Let's do the second example. Okay, so you're told that there are 10 days and there are 5 days that parents visit. The first day, so now we have 1, 2, 3 up to 10. First day it's 12 and 10. Then second day is 0 and 2, 7 and 1, 1 and 8, 3 and 4, 3 and 4, 2 and 3, 1 and 2, 10 and 1, and 7 and 5. So 3, 4, 5, 6, 7, 8, 9, 10. These are the 10 days. And the days that the parents visit are what? 2, 4, 5, 2, 4, 5, 6, and 8. All right? So first of all, anything after 8, I don't care. All this mess, I really don't care. I'm going to just throw that away. Okay? So the question is, how do I manage my first 8 days? Which days am I going to do cleanup? That's the question. And so let's kind of backtrack here. We want to know we want from r of 8 comma j, we need that to be 0 because the parents visited that day, right? So we want to know what is the right value of j in order for this to happen. And so, the table, by the way, the table is going to look something like this. I'm going to have 0, 1, 2, 3, etc. For 0, the amount of mess that I'll have is at the end of the first day. If I do 0 cleaning, right, I'll have 12, then 0, then 19, then 20, then 23, 26, 28, and 29. This is the amount of mess I'll have if I do 0 cleaning. If I do 1 cleaning, then if I do it on the first day, I will be left with 2. And then after that, I'm not cleaning at all. So it'll just add up the rest. So it'll be 2 plus 0 plus 7 plus, well, in fact, the rest will just mirror what I have here. And I'll be able to figure this out. Okay? If I do 2 days of cleaning, then it depends on which days I pick. So, and you have to figure out what leaves the minimum amount of trash. Um, right. So, so over here, it seems like I should be doing cleanup on this day and this day in order to minimize the amount that I have left on later days. But anyways, you can see that as you go along, you'll start to fill up these entries. So we can look at some arbitrary entry here and see if it makes sense for you. So let's say I'm trying to fill up this entry here. What is this entry? This is 1, 2, 3, 4. So I'm looking for R of 4, comma 2. So row 4, column 2. So R of 4, comma 2 means I'm looking at the first 4 days of data. I'm allowed 2 cleaning days. I want to see which 2 days I should do in order to end up with the least amount of mess. Okay? And so R of 4, comma 2, according to this formula, will be R of, so let me write here, R of 4, comma 2 will be R of will be either R of 3, comma 1 plus whatever happened on the 4th day, which is 1 and 8. So I do plus 1 minus 8, or it's going to be R of 3, comma 2. Oh, wait, what did I do? Did I get this right? Yeah. Right? Plus? Oh, plus m of I. Yeah. So m of I is 1. Right. Okay. So it's going to be one of these two, whichever is smaller. So I have to figure out what R of 3, 1 is. Excuse me. So in order to figure out R of 3, 1, either it'll be R of 2, 0 plus, so if I'm looking at the first 3 days and I'm allowed 1 day of cleaning. So either I do R of 2, comma 0, and 2, comma 0 is, we know is 12, right? Plus 7 minus 1. Or it's R of 2, comma 1 plus 7, whichever is smaller. So we have to go and fill this up and kind of figure that out. Okay? Questions? So essentially, you'll turn this upside down and you'll go for I equals 0 to n. For I equals 1 to n, for j equals 0 to n. Here's how you fill this up, and here's the formula. You just plug that in, and it's done. The only issue is the parents' visits, and so you have to kind of take care of that separately, because you have to make sure that on the parents' visit days, the remainder is made 0. Otherwise, you can't carry on. Did that make sense to you, Ian?
I was thinking of something else.
Oh, sorry. Okay.
No, yeah, this does make sense to me.
Okay. All right, we can stop here. That's dynamic programming for you.
You know, all you could just clean every day.
Not that.
No thanks. I'm with Ian there.